Jing, Daniel, and Ruslan from Carnegie Mellon University have come up with this training method, which is called as generating images with large language models, or GILL. This is a training method that enables a large language model and a text to image generator to use both text and images as either input or output. Given text and or image input, it decides whether to receive existing images or generate new one. Let me show you one example and then we will see how it works. If you go to their paper, and I'll drop the link in video's description, on the very left hand side, this is the dialog with this GILL model, and then in the middle and at the very right, there are the comparison with from and also with stable diffusion. Now, if you look at the first one, you can see the difference. The dialog with user started that I am thinking of an animal, it is brown and furry and has a tail, what is it? And then model is asking a squirrel, but then we have given it more pointers, like I'm thinking of that animal which lives in the river. Model said beaver. Then we are asking, okay, show us the illustration of beaver, and then it has shown us the beaver. Then just to make sure, we have asked it to draw a pencil drawing and then a comic illustration, and then look at the quality of the beaver's comic illustration and also the pencil drawing. But when the same thing was asked from the other multimodal models like Fromagi and also Stable Diffusion, and remember that Fromagi is a trivial only multimodal language model, so the image outputs are only limited to retrieval set and nothing else. And similarly, the Stable Diffusion is only generative only text to image model, and that is where you can see that they were able to do something, but the quality is not that good, especially when it comes to the different variations of what we are asking it in the comic illustration and the pencil drawing. Now, the way this GILL model works is that the researchers used a pre-trained OPT large language model and then also the WIT-L image encoder and pre-trained stable diffusion text to image generator. And then the researchers trained WIT-L to map its embeddings to those produced by OPT. They trained OPT to recognize prompts that request an image and enable the system to either generate or retrieve images. Finally, a separate linear classifier learned whether to retrieve or generate images. Then another great thing these authors did, that they froze the WIT-L, added a linear layer and trained it as follows. Given an image as shown on the left hand side, the WIT-L plus linear layer produced an image embedding, and then given the image embedding and the first part of the corresponding caption, OPT iteratively tried to predict the next word. The linear layer learned how to modify the embedding so OPT could complete the caption. This enabled OPT to take images as input. And then finally, they also enabled stable diffusion to produce an image when OPT generated the 8 new tokens. They also trained a separate transformer to map OPT's embedding associated with the 8 tokens. After that, the researchers trained a linear classifier given the 8 OPT embeddings associated with the token to decide whether to retrieve or generate an image. And all this detail is explained in great detail in this model, which is displayed on your screen. So this is what I have described in simple words, which you can read further the whole architecture, how these embeddings and generated captions are working through in this linear to process, linear to produce images or process images. Now, one more thing I wanted to share, that the authors have evaluated GILL's and stable diffusion abilities given the final caption or all 5 captions to generate the final image in each story based on clip similarity scores between generated and ground truth images. Given one caption, GILL achieved 0.581 similarity and stable diffusion achieved 0.592 similarity. But when it came to 5 captions, GILL achieved 0.612 similarity and stable diffusion only scored 0.598 similarity, which really highlights GILL's ability to use the context afforded by more extensive input. So, great stuff, because you can see that instead of generating images, this new system can choose to retrieve them. Because instead of generating a new one, why not just use any existing system which will match the description. So pretty cool paper, I would say. As I said, I'll drop the link in video's description. Let me know your thoughts. Very interesting paper, I would say. I hope that you enjoyed it. If you have any questions, thoughts, please share them in the comments. And if you like the content, please consider subscribing to the channel. Thank you very much.